First of all, we might ask the question, why use computers for counts? And we know that human error in counting is frequent and has been documented in at least one paper as early as 1939. Many of us who work in labs understand that if you have more than one human manually count objects in an image, we're going to have more than one result. Computers at least allow for consistency when making measurements from images, and they do a pretty good job at doing estimates. They may not be absolutely accurate, but you know from image to image that it will have the same level of accuracy. When you do measurements, you know that objects of interest are often on tissue area. So you have positively labeled cells, for an example, on some sort of a background tissue. So generally when you do measurements, you show them as objects per a surface area, per an area. So objects per how much tissue you have those objects on. Here's an example of that. Here on the left we have an H&E stain sample. Part of that sample is eosin stained, and that part we want to get, in this instance, the area of. But it isn't just the area that we're interested. We're interested in the area of the eosin stain per the reference area, which would be the tissue that it's laying upon. We're going to do all steps in ImageJ, and if you don't have ImageJ, you can download a fully powered version of ImageJ called Fiji using this link shown here. And remember that ImageJ won't be fully functional without installing also Java. So one thing that you must do before even beginning this process of doing measurement is to make sure that the images from microscope slides have features that are all in focus. Out of focus features are often difficult to identify. So in order to do that, you will have to make thin slices, or with a confocal, you can use a projection from image stacks. And remember that when doing counts, it's useful to use the lowest magnification in which features can be positively identified. That too will help in creating an image in which all parts of the image are in focus. As an example of what an image might look like were you to use an image with out-of-focus parts, I can zoom in to this image, and you can see that there are out-of-focus and blurred parts of this image that you could potentially count, but would be difficult to identify as positively labeled complete cells. If I were to use a function in Photoshop called focus area, I could also see how much of this image is actually in focus. And once this function runs, you can see that very few of these cells are actually in focus. So here we have an image opened in ImageJ, and this image looks like it's relatively easy to get a measurement from because you can see these very bright cells against the tissue. Under Process, I'm going to use a filter called Find Maxima. And then that maxima has a prominence setting, and I would choose light background, but this is a fluorescent image, even though the background is quite light. And so I will leave that unchecked. I want to exclude any of these cells that are at the edge and not count those. And I can preview then what the point selection looks like. And as you can see, it thinks that quite a lot of the image is the objects that I'm interested in. So what I'm going to do is change the prominence. And in this instance, I already know that it works fairly well at 60. However, if I look at the image, I can see that it's overcounting. And it's overcounting at really tiny spots. So if you look down here in this area, and I show the preview, you can see that it counts this spot, and that spot. And that's because it's counting these little tiny spots that are hardly visible. That tells me immediately that I need to exclude those spots in order to get an accurate count. And that tells me then I need to use the median filter. I'm going to cancel this. Under Process, Filters, I'm going to choose Median. So I can get a preview of what a median filter looks like as I set the radius. I know that for this one, a radius of 1 will exclude all of the smaller spots. Now if I go back into Process to find the maxima, and again choose 60, I'm going to get much more accurate counts. And this looks like about what I would expect for this particular image. And you can see that it didn't count this cell because it's at the edge, nor did it count this one because it's at the edge. And that's appropriate for doing counts. If you want to record your count, you can do that by clicking on this drop down and choosing Count, and then click OK. And you will see your count in the results. The next piece I need to do is to get the background information. You can see that there are some areas here that are holes. So what I'm going to do then is go under Image, Adjust, Threshold, and it tells me it only works with grayscale images. So what I'm going to do then is under Image, Type, I'm going to change that to 8-bit. So under Image, Adjust, Threshold, I'll set the threshold so that it only covers the background area, and so that the darker areas that are holes in the tissue aren't included. So everything red here is being included. And then if I analyze using Measure, Control+M, I can get these results with the area shown. This area is in pixels squared. If I don't get the area, it's because I didn't set up measurements in which I clicked area. Also make sure that Limit to Threshold is clicked and Display Label. So that takes care of one image. Let's try another image. And we'll do the same thing measuring these. Under Process, we'll find the maxima. Again, we're going to preview how much of this is chosen. And then we're going to reduce the amount until it chooses enough in this prominence. And you can see that it does a fairly good job of counting, but in some areas it's over-counting. And the reason it's doing that is because it's showing nucleoli, it's actually counting each one of the nucleoli in each cell, or in some cells anyway. That tells me I need to blur this image. Again, I'll use the median filter, only this time I'll probably use a more robust median filter. I'll just try 10 and see what that looks like. And now you can see that all of these cells have become blurred and they become more individual objects. Looks like I need to set the prominence quite low so that it finds all of them. We can use Process, Find Maxima, and this time we would call it a light background. We'll preview the selection, and then we can change the prominence until we can see that it selects the cells that we believe that it should for counting. Notice that when it does count, we're very concerned with the fact that where you have two cells that meet together, such as here, that it shows two different counts. It may not be perfect. Here's a longer cell where it isn't counting two counts, but you just do the best you can to see where you can get the most accuracy. So once I do that and write down my maxima, then I need to measure the background. Then under Image, Adjust, Threshold, you can see as I threshold it that the image comes in sort of a circular pattern, which shows that this image has a spotlight vignetting issue. Because this threshold setting shows that I have uneven illumination at the edges, I'm going to go back and reset this and then decide how I'm going to proceed. this background is fairly light and the histogram hasn't been stretched. So I'm going to go under Process and use the Enhance Contrast, which is misnamed, and then click Normalize, and then say OK. And then clearly I need to correct for uneven illumination. So to do that, I will go to Subtract Background under Process. And then while I'm subtracting the background, I'll take a look at my rolling ball radius. If I can click Preview here, make sure I click Light Background, since this is a bright field image, and then I can actually look at what the background is, how it appears. And you can see that at a rolling ball radius of 80, it's pretty fuzzy, pretty well fuzzed out. If I go down to 20, you see a little bit more detail in these edges. It's better to have a cloudier appearance with your background than not. So I'm going to unclick this and then say OK, and that should correct for my uneven illumination, which is critical when doing any kind of tonal separation for a threshold. So now with my threshold tool, I'll look at this again, and you can see we don't have the problem anymore of thresholding coming in from the edges with the spotlight effect. But now what we have a problem with is that the tissue area between the darker parts of the tissue aren't filling in. Reset the threshold. And then before I continue, I'm going to duplicate this image under Image Duplicate so that I have a second image against which to compare the first one. And then if I use the Zoom tool and hold down the Alt or Option key, under Process, choose the Median filter. I'm going to choose rather a large radius to blur it dramatically. That way I can see that I blurred all of the tissue together and I can see these areas that are white. And that's a radius of 20 pixels. Now what I want to do is threshold again to see exactly how this works. And you can see now that the areas are blended together, but I still have a problem. While this area here does a fairly good job of being interpreted by the thresholding, this area here is clearly tissue, this area here is clearly tissue, and so it's not exactly getting everything right. So I'm going to reset this one more time, and this time rather than futz with this image, I'm going to instead eliminate some of this outside area of the image by using the rectangle tool and basically cropping the image. It's nice to save that crop so it can be applied to other images. So under Analyze, Tools, something's called an ROI Manager. That's a region of interest. And in that region of interest, I'm going to add this region of interest. And then under Image, I'll crop this image. Now when I go back and set the threshold, I can set it in such a manner that I include only the tissue area, and then wherever there's white and a hole in the tissue, that is preserved. These are artifacts, but we're going to let that go. And then if I wanted to go back and use the same crop on all images, I simply go up to the ROI Manager here, click on it, it places the cropped rectangle in exactly the same position, and then under Image I can crop that image. One thing that I didn't talk about is the fact that this image is a JPEG. Part of the reason we're having so many troubles with this image is because it's a JPEG image. It is best not to ever work on JPEG images. Here we have a fluorescent image. This image contains saturated pixels, and so this image would need to be retaken without saturated pixels for measurement. But we'll work with it anyway. Let's start actually by creating a duplicate image. so that we have a second image from which we could then get the tissue area. And now let's go under Process and use Find Maxima. It doesn't have a light background, so I'll make sure that that's unclicked. I'll click the Preview Point Selection, and immediately at a prominence of 20, immediately you can see that it's picking out non-specific tissue background area. So I'm going to cancel, and remember always to cancel, click Cancel, and then under Image, Adjust, I'm going to change the darkness of the background, and so I'll use the brightness and contrast, and then click on the minimum to eliminate all the background information, and then click Apply. And it will give me a warning. Simply click OK. Find Maxima again, and then see if it does any better. And you can see it does. It actually no longer picks areas that are in the background. However, it chooses one cell and picks 3 counts. And in this cell you see it picks 2 counts. So that's incorrect. I'm going to click Cancel. And then I realize that there's varying levels of brightness in each one of these cells. So that tells me I need to smooth that out. So under Process Filters, I use Median. And then if I click on the preview at a radius of 4, I can see that it does a fairly good job of blending. Now if I go in under Process, Find Maxima, I can again preview my point selections, and this looks much better. Now I don't see overcounting for any one cell. This one's overcounted by a couple. But otherwise it seems to do a fairly good job of choosing the number of cells that are in this image. Obviously, because I exclude the edge maxima, it's not going to include any of these cells that are half over the edge. Still, I have one problem, and that's that there's some background fluorescence here and background fluorescence here. So I'm going to cancel again. This time go to my paintbrush, and then I'm going to fill in these areas. Now it'll fill it in with a color that you choose under Edit, Options, Colors, and make sure your foreground color is black. Say OK. And then you can just paint this out here and paint this one out here. And then again under Process, Find Maxima, we preview the point selection, and now we have a much more accurate count. Now how do I know that a count of 211 is accurate? Well, because I did a manual count and I came up with an amount of 214, but I also included some of these cells that are at the edge. And I decided that these oversaturated areas would be counted only as 1. So this time I'm going to write down the maxima, and then of course include some kind of error bars for occasional miscounting when I present the data in the paper. And then on this image I'd like to include only the background, so I have a count per tissue area. So under Image, Adjust, Threshold, I'm going to attempt to only threshold the tissue area, account for holes that might be in the tissue area. But as you can see, it doesn't do a very good job, and it's really hard to find actually any holes in this tissue. The tissue area simply isn't bright enough. So to solve that problem, I'd either A, have to have a second image that has very bright background, or B, I simply choose the entire area of the image, and then that would then be my reference area. Analyze, Measure, and then here is that area. Here we have another color bright field image. You'll note that with this color bright field image, it's hard to see the darker blue staining against this red. So the best thing to do in that instance is to split the image into its color components. So you split channel. And I see that the blue channel really doesn't contain any information I'm interested in, and so I'll kill that. In the green channel, I can see the empty areas that are shown here. So these are holes in the tissue. And if I choose the red image, it's pretty easy then to see the stained parts of the image that I'm interested in. But obviously we don't want the entire image. I'm going to use the outline tool to then outline the area that I'm interested in. I'll just roughly do that. And then under Analyze, Tools, ROI Manager, I'm going to add that region of interest. And we can see that it does a fairly good job of finding the points. I would think it should find a few more. And this time I'm going to do something that isn't generally done with images of this sort, but you can see that it's fairly blurry. And normally you want that, but in this instance we actually want to separate out each one of these individual areas, or each one of these individual points. So the best way to do that then is under Process, Filters, use an unsharp mask filter. I'm going to use one that's just the generic filter, and that should do a fairly good job of making them more distinct. So I'm going to say OK. And then under Process, find Maxima. We'll again look at the maxima, and we can see that it's choosing more points along these areas. Now let's go to the other image, and this is our reference image, and let's threshold that. But first we need to add the same region of interest, so I click once, and then under Image, Adjust, Threshold, and here is my area in pixels squared. Now if you don't want to do pixels squared and you want an area in another unit of measurement, under Analyze, Set Scale, you can put in the known distance and you can give it a unit of length that's different than a pixel. So far we've been making the assumption that all images are exposed identically, and if you apply the maxima prominence value to one image, you can apply the same maxima prominence value to another image. But when images are different in terms of brightness or contrast, they need to be made identical. This can be done in Photoshop using the match color method. But if you're in ImageJ, this is how you would make your images all identical. Under Process, Enhance Contrast, and we'll use saturated pixels of 0.3. We'll click Normalize, and then go to the other image and do the same. Under Process, Enhance Contrast, Normalize, OK. And so now you've done a fairly good job of matching the contrast and brightness of two different images. Now let's make a macro so that we can use the same settings on other images and go quickly. First, before doing a macro, if you have an outline, you need to make the outline first. So I'm going to make the outline the region of interest, and then add that region of interest to the ROI Manager, Region of Interest Manager. So we got that done. Now let's go ahead and record the macro. Under Plugins, Macros, choose Record. Now what we need to do is to edit the macro to make sure it will work on other images. So here we see in the macro that we can create a macro that we can then edit. So we can close this. And then let's go ahead and edit this macro so that it works on other images. And we see that it's going to run split channels, but then it wants us to select a window. Whenever you see select a window, you eliminate that. And we'll go down. Here's another place where we're selecting a window. Let's eliminate that. And it looks like it should be able to work on our image at this point. And then here we'll just click Run. And it looks like we've got our area for the first part of our image, and we also have our count. So everything worked. You can then save this to a place where you'd like to save it. Your results you would like to then also save, and these can be CSV files. If I need to use the plugin again, I'll have to go to macros. I prefer using edit. I can find that macro here, open it, and then use the run routine on other images.